In this section, we'll talk about random error versus systematic bias in collecting data on surveys, common errors in memory, and problems with collecting data as part of an NGO, and also asking about sensitive information on surveys. In the previous section, we dealt with problems that arise due to biases in sample selection. Here we'll talk about biases that arise in reporting information incorrectly on surveys. People don't perfectly remember facts about their financial situation and other details, and this means that some answers on surveys will never be 100% accurate. If respondents to a survey just randomly report figures that are higher or lower than the true values, then this will make it more difficult to identify the relationship between variables. So for example, if you're looking at the effect of a livelihood intervention on income, it's going to make it more difficult to estimate the effect of the intervention. However, in this case, in which respondents just randomly remember things incorrectly, then increasing the sample size will improve the accuracy of the estimates that are produced with the survey data. Better designed survey instruments that carefully elicit information can also minimize error. A much more serious problem is when information reported in surveys has a systematic bias. This occurs when the error is not random, but rather it's more likely to be higher or lower than the true value on average. To illustrate this, we'll go over an example. Consider a survey that measures schooling and income. People in the population with more schooling earn more money on average. If we could somehow observe the true values of income, so this would be perfectly reported with no error, we might observe something like this. On the horizontal axis, we have years of schooling. On the vertical axis, we have income. So this is just a hypothetical example, so don't really pay attention to the units here. You can see here quite clearly that as schooling increases, so does income. We would expect to see this in plenty of real-life situations. The red line represents the average effect of schooling on income, and the slope of the line shows how much an increase of, say, 1 year of schooling increases income on average. Next, we'll consider a case in which respondents to the survey report higher or lower incomes than they actually earn, possibly because they don't have good records of income or for some other reason they don't have the exact figures. To clarify here, we're talking about random variation between true income, the amount of money that people actually earn, and the amount reported in a survey. We're not talking about variation in the income itself. As long as everyone is equally likely to report some number higher or lower than their true income, then this is random error. While the values of income that are reported are more spread out than the actual values, the average value should be the same. The graph might look like this. So here the blue dots are true incomes and the red dots are the reported incomes. These are higher or lower than the true values, randomly. Notice that while the red dots are more spread out, the average is actually the same. And importantly, the line that represents the average level of income for a given year of schooling is still the same. That means that the effect of schooling is estimated to be the same, meaning that an increase of 1 year of schooling still produces the same increase in income on average. Random error just makes it more difficult to observe a clear relationship between two variables, like school and income in this case. However, we can expect to get the same result of the effect With random error, increasing the sample size will increase the predictive power of the survey. So in other words, the more people we survey, the more likely we are to get the true result. But what if the error in reporting is not random? What if the ability to remember income is correlated with schooling itself? It's possible that those with more schooling keep more detailed records of their income, and thus they're more likely to remember the income that they make. Moreover, people with less schooling might be less likely to have formal jobs and may earn income from multiple sources. This makes it more difficult to remember all of the income that they've made. While the real world is obviously much more complicated than this, we've simplified this example to illustrate the point. So, here we're assuming that all people report less than their true income, and that those with less schooling are more likely to forget about some of the income that they've made, and thus report smaller incomes than the true level that they've earned. Here, we see that the average effect of an extra year of schooling on income appears to be much greater for the reported values, which are represented here by red dots, than it does with the true values, which are in blue. This is because the difference between the true value and the reported value is larger for people with less education. In other words, an increase of 1 year of schooling looks like it increases income even more than it did before. This is called systematic bias in reporting, and it's much, much worse than random error. Importantly, with systematic bias, increasing the sample size by surveying more people will not solve the problem. So, what is the solution here? Unfortunately, there's no easy trick to solve this problem. The answer is to design carefully worded survey questions and ask about the most important information in several different ways. Continuing with the example of income, you can ask about different sources of income, and then ask how much money was made from each one of these. And asking about income over different periods of time can also help to get better estimates. Go through surveys and try to anticipate potential sources of bias, and then decide how to ask more specific and detailed questions where it's appropriate. Finally, you should just be aware that some bias will exist in your data. Then, during the analysis, you should look into this and interpret the results accordingly.